So, what do a nightclub bouncer, your credit card, and Netflix's streaming servers all have in common? I mean, at first glance, they seem completely unrelated, right? But if you really look closely at how they function, they share one absolutely vital characteristic. They are all gatekeepers. They stand right between you and the thing you actually want, making sure everything is totally legit before letting you through.
Welcome to This Explainer. Today, we're going to demystify one of the absolute most powerful structural concepts in software engineering. We're talking about the proxy design pattern. We're going to see exactly how it acts as an intelligent intermediary in modern software, controlling access and adding massive value completely behind the scenes.
Okay, let's look at how we're breaking this down today. We'll start with the everyday proxy, define the pattern, look at some big tech uses, dive into the UML and code, do a little disambiguation, and then wrap up with our final takeaways.
All right, Section 1, the everyday proxy. Let's ground this with some real-world analogies.
Think about the very last time you swiped your credit card. That little piece of plastic, it acts exactly as a proxy for your actual bank account. It shares the exact same interface. You use it to pay for things, but it controls access. It validates your PIN and checks your balance before the actual transaction even happens. The same thing goes for a security guard at a building. The guard doesn't actually perform the work inside the building. Thankfully, they aren't in there doing your taxes. They simply decide whether your request to enter should go ahead. The proxy looks exactly like the real object to you, the client, but it controls, protects, and manages access before the real object has to do any of the heavy lifting.
Moving right along to Section 2, defining the proxy pattern in software architecture.
So the crucial point here is that a proxy is essentially a surrogate or a placeholder. By decoupling the access from the object itself, you get total control over that object's lifecycle. It sits right there, directly between a client and a real object. Clients use the proxy in the exact same way they'd use the real thing, but the proxy gets to decide exactly how and when that real object is accessed. It's intercepting calls to validate requests, maybe delay expensive object creation, cache results, or log activity. It's doing all the dirty work.
Just imagine what happens without a proxy. Like when a client directly hits a database. You've got no authentication, no logging, no caching. Expensive objects are just constantly created, even if they aren't fully needed yet. Honestly, that is a recipe for a sluggish, insecure system. It's literally like leaving your front door wide open in a bad neighborhood. But by simply dropping a proxy into the middle of that setup, you instantly gain this incredibly powerful intermediary layer that gives you control, protection, and performance. And the best part? You do it all without changing how the client actually asks for the data.
Which brings us to Section 3, real-world software uses or proxies in the wild.
Have you ever wondered how ChatGPT rate limits your prompts so their servers don't just completely melt down? Well, when you hit that limit, a proxy stops your request cold and fires back an error before the massive, expensive AI servers even know you asked a question. Or think about how Netflix checks your subscription and your region before playing a movie. They are heavily utilizing proxies behind the scenes. When you hit play, you aren't directly talking to the main streaming server right away. You're talking to a proxy that checks your parental controls and your billing status. Only then does it forward your request to the actual movie object. It handles all these checks totally seamlessly, so your user experience never skips a beat.
Now, depending on what a system actually needs to accomplish, we can deploy a few different flavors of this pattern. For instance, a virtual proxy is heavily used for lazy loading. That means delaying the creation of a huge image file until you actually scroll down to it on a web page. Then you've got a protection proxy, which is all about authorization, making sure only a qualified doctor can access medical records and not the front desk receptionist. A remote proxy makes fetching data from a cloud database feel like a standard local method call right on your machine. And finally, a cache proxy, which just remembers previous results so your system doesn't have to do the expensive math twice.
All right, let's roll up our sleeves for Section 4. UML and code implementation. Time to look right under the hood. Now, the UML architecture for this perfectly proves the pattern's golden rule. Both the proxy class and the real subject class point up to the exact same subject interface. And because they both implement that same interface, the client treats both objects in the exact same way. The client depends on abstractions, not concrete classes. This guarantees total transparency. I mean, this is the magic of polymorphism at work. The client literally never knows if it's talking to the real deal or just the proxy standing in front of it.
Let's actually see this in action with a Java implementation for a banking app. We've got an interface called account. Both our real account and our account proxy implement it. So, when a user tries to withdraw, say $1,500, the request hits the account proxy first. The proxy grabs it, verifies the password, checks to make sure the user hasn't exceeded their daily withdrawal limit, and then, only if all those checks pass, does it forward the request to the actual real account to perform the withdrawal. Because the account proxy implements the exact same interface, we didn't have to rewrite a single line of the client application to add this massive layer of banking security. Pretty slick, right?
Let's clear up some common confusion in Section 5. Proxy, adapter, or facade?
To keep these straight, just lock these mental models into your brain. An adapter is like a travel plug. Its whole goal is to convert an incompatible interface so two things can finally work together. A facade, on the other hand, is like wearing sunglasses. It hides the blinding complexity of a massive subsystem behind one simple, easy-to-use interface. But a proxy? A proxy is your security guard. It doesn't change the interface like an adapter, and it doesn't simplify a whole subsystem like a facade. It strictly controls access to one specific real object.
We've covered a lot of ground, so let's synthesize everything in Section 6. Final takeaways.
To summarize all of this, the proxy works exactly like the real object to the client. Because remember, they share the exact same interface. The client is just blissfully unaware that it's communicating with an intermediary. Meanwhile, our proxy is secretly acting as an incredibly intelligent gatekeeper, adding immense value. We're talking lazy loading, security, caching, logging, and it's doing it completely in the shadows. It promotes transparency while drastically improving both security and overall system performance.
Let's actually test this out on some everyday developer situations. Say you're building a hospital login system. You definitely need a protection proxy there to strictly enforce user roles. Or if you're delivering web content globally, you absolutely need a cache proxy at your CDN edge servers to reduce the load. Or maybe you're building an online exam portal. Well, a proxy is totally perfect for verifying a student's identity before they can even access the test questions. These are real, everyday problems that are perfectly solved by simply dropping a proxy into your architecture.
So, I'll leave you with this final challenge. Take a look at the software or systems you're building, or even just interacting with today. Think about your biggest performance lag, or maybe a nagging security vulnerability, and ask yourself, could implementing a proxy be the secret ingredient you need to solve that bottleneck? Because sometimes, the absolute best way to fix a problem isn't to change the real object at all. Sometimes, you just need to hire a really smart gatekeeper to stand in front of it. Thanks so much for joining me on this explainer, and keep building smart.